Good afternoon, everyone. My name is Ashley Howard Neville. I am a senior technical evangelist for Tableau. And that's just a really, really fancy way of saying I know our software pretty good, and it's my job to go talk to people about it. To not sell them on it, but to empower them to understand our software, the philosophy behind our software, and how they best can use our software. I get to do a lot of fun things in this job. I get to work with our product development team on new features. I get to meet with our user research team who does studies to try and better understand how people like you use our software so we can make it the best it can be. And then my funnest job of all is I get to help with the keynotes. And I get to help design all of the vizzes that you guys see up there today. So I have brought those vizzes here, and we are going to spend some time looking at the vizzes that were in keynote yesterday and devs on stage this morning. And we even have copies of the Iron Viz vizzes to take a look at a little bit later. And we're going to accumulate at the end of this talk. We're going to talk about best practices. We're going to look at them in practice, and then we're all going to pull out our phones and vote on which Iron Viz we think best applied visual best practices, and we're going to crown a best practices winner to the Iron Viz. So as you're learning and listening for the next 40 or so minutes, keep what you saw yesterday in Iron Viz in mind, because we're going to talk about that in depth at the end. My Twitter handle is @DataAshley. Feel free to tag me, take pictures. And then if you run into me in the hall, love to chat more. So we're going to start with a couple of games. I want you guys to, I'm going to put something up on the screen. I want you to figure out how many of the object there is. Ready? Raise your hand when you got it. Okay, hands went up pretty fast. How many are there? I heard a 10. There's 9 up there. And but this is my point exactly, is that the way we get to this number is we actually sit there and count each dot here. So when this went up on the screen, you were like, okay, 5 on the top, 4 on the bottom, that's 9. So that's our brain processing and thinking, and it takes a bit of time. How about, put something up on the screen. How many 9s are there? 64? Any others? Many? Many? This is a lot harder. Our brain did the first one really quickly. How many? I'm still hearing lots of answers. How about if I do this? Is that easier? Yeah, how many are there? 11. So it took me coloring it for us to get the answer right. How about when we make data more complicated like this? How many 8s are on that screen? I don't know. I don't expect you to know either. There's a bunch of decimal numbers in there. But this is a crosstab. It's a spreadsheet. It's really, really hard for our brains to comprehend what is happening. And that's because when our eyes take in information, it actually passes all the way back to the back of our brains, so back here. And we have what's called a visual cortex layer here. And our brains have been adapted to be able to, they're not adapted for numbers. Maybe if we keep on this industrial age and this digital age, 10,000 years from now, our brain will adapt to the numbers, but they're not. Our brains are actually adapted visually. And so when you see berries on a bush, when you see a tiger's movement, these are all things that our brains have evolutionarily evolved to be able to best leverage. And so where Tableau comes to the table is we say, we don't think that you should be doing math to understand numbers. We think that there's a faster and a quicker way. Because when I show you a picture, your brain can process it in milliseconds versus taking 5, 10, 20 seconds to get to a number. And that's really the core of what Tableau is rooted in. It was actually our second patent is something called VizQL. And it's an actual language that translates numbers into pictures. And it's core to Tableau. There's no other data visualization software out there that has this language. And thankfully, we have the patent for a little bit longer. But that's what's powering Tableau underneath. It's not some wizard that you're going through and clicking and saying, I want a chart type. Let's pick donut. Let's add in some values. We're trying to get your brain out of that space of thinking into a place of reacting. So let's go ahead and look at this set of numbers in Tableau, because this is actually a really special set of numbers. Has anyone ever seen these numbers before? I got a hand up there. What's special about these numbers? What? They have the same 4 statistics. So let's go ahead and jump over. We're going to do a little jumping back and forth between Tableau and here. So this is that same set of numbers here. And I go ahead and if you're sort of new to Tableau, Tableau, this isn't the friendliest form for a computer to read. So I've actually gone ahead and unpivoted this data here. You can see I have those x, y coordinates still, and I have that set with the point. And I'm going to go ahead, copy all of this data, and we're going to go paste it into Tableau. So let's go ahead and we'll open up a new sheet. That wasn't the workbook I expected to open up. Here. Autosave, great feature. OK, so went ahead, Control-Z, pasted this in. You could also drag a file into Tableau. But if we go ahead and open this up, I'm going to make it bigger for you all. It's really small, unless you have like eagle eyes. Let's go ahead here and hit Format and make this a little bit bigger for you guys. Is that a little bit bigger to see? OK, so all of these here I have a set, and I have an x and a y. Everyone see that? And I can go ahead and change this. Right now, there are some. I can change this to an average. And all of these actually have the exact same number. So I'm going to change this from an average to a median. And the number is actually going to still hold. And this is a very special set of data for this. But each of these sets of data is very different. They're very different from one another. So let's go ahead and create a new sheet. And this time I'm going to grab set and x and y. And this time I'm going to use show me. Who knows show me? Lots of hands. Most people get started with show me. Show me is a really great feature. And I'm going to go ahead and make a visualization with this data here. OK, I have sets, and I'm going to go ahead and pull out my point. Let's see. We got x, we got y here. This wasn't the workbook I expected. It was supposed to all automatically do this. We're doing this on the fly together. So I have my x, I have my y, I have my set, and I need my point. Here. And you can see that Tableau is now drawing all of these values that we had before onto the visualization. Let's go ahead and make that a little bit bigger for you guys so you can see. It's drawing all of these numbers. And it's automatically coloring these based on that set. So the first set is blue. I'm going to go ahead and click on it here. And we can actually see the distribution of these blue dots here. And this is if you look at it, it's just sort of a widely dispersed, there's sort of no rhyme or reason, no trend to these blue dots. How about if we click set 2? A pattern starting to emerge? Do you see something in that orange? How about if we move to this one over here, set 3? Anything interesting popping out to you? How about this last one? Here. I'm going to go ahead and make that dark for you. There. Anything jumping out to you in that set? How about if we split these up side by side? Even though they have the same average and the same sum and the same median and actually the same standard deviation, these statistical principles that we heavily rely on, these data sets are very different. But it's not until we apply visual best practices, it's not until we allow our brains to access our preattentive attributes, do we really start making sense of the data. Okay? So preattentive attributes allow our brain to very, very quickly process data within milliseconds. But not all preattentive attributes are equal. So let's jump back to PowerPoint for a second here. Here's our PowerPoint. So we are going to start with another game. So I want you to go ahead and find in this next game the one color for which there's only one block. Anyone figure out what color only has one block? Light blue. It's sort of mixed in there. It's a little bit harder to see. Okay, how about this next one? Dark blue. Got some hands? Awesome. How about this next one? It's pretty easy. How about this one? Right? It got progressively easier to find that one color dot. And that's because we were leveraging that preattentive attribute, that innate sense that our brain has of understanding color to encode information. And so, so one of the sort of pioneers in this field is Kelly Martin. And Kelly Martin unfortunately passed away earlier this year. But she brought color theory to data visualization in a way it hadn't been before. So if you want to know more about color, I highly recommend you visit Viz Candy, all of the things she wrote. But what she did was she applied this principle that we had in that last data visualization of using a grayscale and then using color to draw attention to the thing that mattered. She didn't just put color anywhere. She put color where it was really important for you to see and understand. So this was a data visualization she made back in 2013 on bird strikes. And you can actually see very quickly the yellow stands out. Do you guys see the yellow standing out there? And what she was saying is that most bird strikes actually happen during the day. 62% of bird strikes happen during the day. But more importantly than that, she said that she shows that bird strikes happen very close to the ground, and they happen very high up in the air. Those are sort of the two places that bird strikes happen. You can see that in the visualization. And then she has colored those on or created the size of them on the number of strikes. And so this is a visualization that is sort of applying best practices of color. Okay? So we sort of found out earlier, we can highlight things with color, we can encode that information even more, we can combine that with something like position. Now I'm gonna, and size to add more information to quickly get to an answer. And we're gonna get to the last one here. So we're gonna do one more game. It's called What is Different? Okay, so what is different? Red. I'll do it really quickly again for, that one was pretty easy. Okay, how about this one? Circle, okay. I'll show it again for those of you who, everyone find the circle? Okay, how about this next one? Oh, that was the one from before. Okay, how about this one? There we go. I'll show it a couple more times. Everyone feel like they found the thing that's different? Okay, let's see if I can can force it up there. There you go. Anyone see it now? I put a little circle around it. So there is a red circle hiding amongst red squares. Everyone see that? All of the other circles are green, but there's one red circle up there. And so this is the last piece of data we can encode. We looked at position, we looked at size, we looked at color, and the last one is shape. So I want you to look at these two data visualizations I'm going to put side by side. Which is easier to understand? The one on the left or the one on the right? The one on the left is coloring regardless of shape. The one on the right is segmented by shape instead of color. But the one on the right looks completely random to our brain. And this is actually what Where's Waldo leverages. This idea of combining color and pattern together to trick your brain into not being able to find things. So we played some games, and I hope that the games just reinforce to you the sense that these things actually do matter. That the colors that you choose, the patterns that you choose, the size that you apply in your viz all matter to your data visualization. And they matter for two reasons. The first is they can make it really quick and fast for you to find insights in your data. But more importantly than that, when you share your visualizations with someone else, you want them to take away the same meaning that you found. And if you cross the position and size and color and you don't put the right measures on the right items, you're emphasizing the wrong things to someone else, and they're not going to understand what you're saying. So there's actually a lot of preattentive attributes. There are about 10 that really matter. So the first one is the length of a line. This is position. Same thing with width. Width is also position. The next one is orientation, and then size, shape, enclosure, the 2D difference. So we saw that in that first example that we looked at, where we looked at the distribution of those statistically similar data sets, right? The 2D position was different. Grouping, color, and then intensity. And intensity is sort of the light to dark shading that we saw. So these preattentive attributes all have a best practice associated with them. Some of them you can use to denote the order of things. And for others, they help you understand quantity. And so we're going to walk through those here really quickly. So we're going to look at size, color, intensity, and color hue. Remember, those are two different things. Orientation and shape. So if you want to explain to someone quantity, the only preattentive attribute you can use for someone to effectively understand is size. So when I'm making a data visualization, I look at my measures and I say, what is sort of the most important numerical number for me to communicate? And I start by putting that on size. The next thing that you might want to look at is order or rank. What is bigger or smaller? What came first, second, third? And you can use that on size, or you can actually use that on both types of color. The gradation of color is important to help you understand the ordering of something. The next thing is selection. And selection is something that stands out from the rest of the group. So say an outlier. And for those, you can use size if you haven't used it already, color, or the one new thing you can use for that is orientation. And then finally, association. Association is grouping. Does this belong with other things? And so you can use any of them, but if you've used all the rest of them before, that's the one you use for shape. That makes sense? I see some pictures taking, so I'm going to hold off on forwarding this for a second. The PowerPoint presentation will be available afterwards if you would like to have it up on the TC website. So all for you taking pictures, but if you want these slides because you want to reference them later, they will be available. So there's actually an ordering in our brain of how important things are. This is a much more detailed version of what I just showed you. But what I'm trying to get at some of these things, quantitative things, right? That's the first one we talked about. There is actually an order of importance in your brain that you rank things. And you can see on the bottom that texture, connection, containment, and shape actually don't apply to quantitative at all. If I say a circle, triangle, and square, you have no idea what is more or less than another, right? And so that applies to ordinal, that rank 2. And then finally, categorical. I'm drawing your attention to the very last line on this slide if you're sort of looking and trying to understand what I'm doing. Categorical means maybe furniture sales versus home office sales versus, what's the last one in Superstore? I'm blanking on it. We've got, office supplies. I can't use something like volume to communicate that, right? I have to use something like color, which is at the top of the list, blue, orange, red. So don't expect you to memorize this slide, but what I want you to take away is there is an order of importance for these things when you're messaging. So this is the order. Color is more important, position is most important, shape is least, and size is less. This isn't, though, a really effective way of communicating this. I could actually apply this best practice to this list. So instead, if I rank them, I position them in order from most important at the top to least important at the bottom. It's a little bit easier to understand. Position comes first, then color, then size, then shape. Now, how about if I add size to it? It's starting to become more apparent that position is important. And then if I imply intensity, it gets an even stronger message. And finally, I'm going to add some color on top to denote position. So if you take one thing away from today, this is what I want you to take away. That in our brains, position is the strongest factor for us to understand data. Then color, then size, then shape. So as you're building data visualizations, think about position first, color second, size third, and shape last. Tableau tries to do some of this heavy lifting for you. So underneath Tableau, there are best practices that are already applied. And these are the rules that Power Show Me. So you can see the viz types on the left, and there is a rule underneath. So if we're looking at the horizontal bar, there's one quantity element, and so that is what Tableau is going to show you. If you have two quantities and two categorical information and one quantity element, Tableau is going to show you a stacked bar. If you have one continuous date and one quantity, you're going to get a line chart, and so forth and so on. And so if you've ever noticed when you drag something out in Tableau and it starts building stuff for you, this is what's powering it underneath. So when you start out, that's really, really helpful. And then it gets annoying. Yeah? Everyone here experienced that? Where you drag something out new on the screen because you want to build something specifically, and Tableau just like goes and does its own thing, and you're like, what the heck? And that's because Tableau is trying to apply one of these best practice rules on top. I know it's annoying. I wish there was like a way to go turn that off. It would totally make my life easier, and I bet it would make your guys' life easier. But do know it's Tableau's best intentions at heart when it does that. It's not being glitchy, it's not being strange, it's not possessed by some dead relative. It's like really trying to help you out with the best practices. All right, so we're going to go ahead and we're going to jump into Tableau here in a minute because I want to talk with you about how you apply these things to Tableau yourself. So everyone here has used desktop before? Yeah, raise your hand. I got some strong lines. How about if you've been using desktop for less than 3 months? Raise your hand. We got some pretty newbies. Welcome to the data family. All right, so if you, we'll just do a quick overview of Tableau and then we'll jump in. So Tableau has these shelves, and you can drag a pill out onto a shelf, and Tableau will create a visualization for you. So that's the premise of Tableau. And there are different places where you can look for position, color, size, and shape. So position is denoted up in the top with rows and columns, and color, size, and shape are all set on the marks card. So let's jump over to Tableau. It opened up this viz earlier, so now I gotta find it. Okay, who remembers this viz from yesterday? Yeah? So Anne told us yesterday in the opening keynote that she was afraid of aliens. So I asked her if we could borrow this data set here. So she's using color to denote seasonality in this viz. Let's go ahead, jump out of full screen mode here, and let's go create a visualization together about UFO data. So I know this is small up here, but I'll try and talk you through it. So when we create a visualization, the first step that I always do is I choose the dimensions and measures that are most important to me. So in this case, I want to understand in what season, winter, spring, summer, fall, had the most alien sightings or UFO sightings. So I'm going to go ahead and click season, hold down my control key, and click number of records here. So I have 2 things highlighted. If I go over to show me here, Tableau you can see is highlighting some of these vizzes. And what Tableau is saying is these are vizzes that match best practices. So I want you to pay attention to what happens when I click on one of these visualizations. I'm going to click on this bar chart right here. You guys see what happened? I'm going to undo it, and we'll do it again. Tableau took these fields and put them out on these shelves. So number of records is on columns, and season is on rows. This is very dark. Here, we'll make that bigger for you guys so you can see it here. Right? I got fall, spring, summer, and winter here, and I can very clearly see that summer is the longest bar chart. Tableau was applying those rules of position first to this visualization. Okay? Now what happens when I change this from a bar to a heat map? Oops. In this visualization, we're no longer looking at position, we're looking at size. Okay? And to achieve that, you will notice that this number of records, green pill, is now over here on size. If I want to get back to a bar chart, I can take this pill and drag it back to columns, and Tableau will draw a bar chart again. Okay? Take this and drive it back and drop it on size, and I'll get that heat map again. Okay? Do you guys see what's going on? A pill is an instruction for Tableau on what to draw. This is the second thing I want you to take away from today. There's an order to things. You can influence that order by where you put the pills in Tableau. So if we want to make this easier to see, I can copy. I'm holding down Command on my Mac, and I believe it is Control on a PC. I'm copying this field, and this time I'm going to drop it on color. Did you see that slight shift difference that Tableau made here? I'm going to undo it and redo it. See that like slight difference here? Some nodding of the heads. Okay. That's because Tableau is applying a gradient from the least value to the biggest value. Okay? And you can influence this gradient by clicking here in the menu and clicking on Edit Colors. Here, and this brings up a whole menu. Does that make sense? That we can look at. We're going to come back to this menu in a second, because sometimes this menu can be a little finicky. Okay? I am going to go ahead this time and instead of putting number of records, I'm going to go ahead and copy the seasons and drive it and drop it on color this time. And instead of using a gradient, Tableau is applying a different color to each of the seasons. Okay? So that's a categorical color. There are two types of color legends in Tableau, and you access the different types of color legends if you're using a green pill or a blue pill. So a green pill will always give you a gradient. A blue pill will always give you distinct colors. Tableau is applying best practices to the colors. So this time I'm going to look at these colors here, and you can see that there's a different set of colors being applied. And Tableau actually has a bunch of built-in different colors here. I really like Nerello Stone, and I think it's a beautiful color palette here. Let's go ahead and apply it here. But one of the things that I love about this palette is named after our researcher who specializes in color at Tableau. So all of the color palettes that are designed and set in Tableau are designed to have the biggest visual differences between the colors. So it's really easy for your brain to comprehend the different colors. There's about 20 different shades that your brain can very quickly pick out. Your brain can actually tell apart about 1 million different colors if you put them side by side. But when you want quick and ease of use, there's about 20 colors that your brain understands. And those are called the Tableau 20. There are 10 main colors with a hue difference from dark blue to light blue. Okay? And so what I recommend is all of these color palettes are really great for you to use because you have the confidence of knowing that your end user will be able to tell those colors apart really well. Okay. So let's go back to that gradient color. I'm going to go ahead and take number of records, drop it on color this time, and I have now that gradient again. You also have control over that gradient if you go into Edit Colors here. And Tableau, again, has different gradients that you can use. Okay. What I like to do is I like to do two different things when I use these palettes. I actually like to use stepped color. Stepped color takes and segments the gradients to help me see groupings a little better. So I can layer on association on top. And then I like to use the advanced feature down here. This allows me to control where the color starts and where the color ends. So if I want to say, make these colors stand out a little bit more, I can go ahead and say, well, anything that's maybe over 1,000, I want to be the same color here. And I can affect the color. And you can sort of control the color that way. Does that make sense? All right. So we talked about position being on the XY axis. We talked about size. We talked about color. The last one is shape. So shape is hidden. We hide it because we don't want you to use it a lot. That is because shape is the hardest for our brains to understand. So shape is hidden on the drop-down menu on the marks card. And when you are on shape, there's a new selector here. Okay? And if I click shape and more shapes, I can go in and affect this. So this time, let's go ahead and put season, fall, spring, summer, or winter, on my shape. And Tableau is just applying random shapes to us. But there's a whole menu. So let's go ahead and use filled because they're easy to see here, and tell Tableau to assign a palette. Shapes are hard because our brain doesn't have any association with them. That's why they're the hardest thing. And so often what you see in a data visualization, you might see a scatter plot that has like 27 different shapes on it. And your brain really can't comprehend what's going on. Okay? So we recommend use shapes sparingly, use shapes for emphasis of something, and often use shapes to just denote one difference or one change. Okay, so let's go ahead and now apply these together to answer a question. So I want to answer the question of, are alien invasions increasing or not? That was the question that Anne had. So let's go ahead and look at number of records, date, and season all together. Okay? I'm going to look here, and I'm going to go ahead and pick my bar chart and see what happens. Oops. Let's go ahead and format this so you guys can see it. And so Tableau defaulted. I'm going to go ahead and hide these nulls for you guys. There you go. So we can look at this data, and what we are seeing, let's go ahead and make that black and bigger for you. We are looking at year-over-year trends between 2018 and 2019. And this isn't a full data set, it only goes back about 18 months. And this is actually, you can see position-wise, is really hard for our brain to comprehend. Even though there's lines between fall and spring, I can sort of tell that they are longer. But it's much easier for our brain if we go ahead and move year under season. And now my brain is able to understand position by drawing a vertical line. And I can now really easily tell that 2018 is lower than 2019. Does anyone know why our brain is really good about drawing vertical lines? Any guesses? What? Horizon. That's actually, I've actually not heard that one as many times as I've asked. It's really interesting. Any other ideas? Here's the hint. You've been training your brain since you were about 5 years old. Reading. So our brain is really, really good at drawing vertical lines because when we are reading, we read over, and then we come back to the same spot to read again. And so every book and line you've read from See, Spot, Run until now has been training your brain to strengthen the muscles to tell the difference between two vertical places. And so in other cultures, in China in particular, they're actually much stronger than Americans in vertical lines because their traditional language runs vertically, and they've actually been training their brain to run vertically. In some cultures like Arabic, where they write from right to left, they're actually stronger at drawing lines the other direction. So in America, we are really good at drawing them horizontally. In China, they're really good at drawing them vertically. And so we can go ahead now, if we want to tell our story, and apply this to color further. We're making a stronger case, and then I can apply it to size as well. Does anyone know why size is really hard for our brain? It's relative. Yeah, it's the reason why we don't like pie charts around here. I mean, we like pie, we just don't like pie charts. And that's because it's really, really hard for your brain to calculate area. You can sort of tell the relativeness of things, but you can't understand the deep differences. So you can tell, like, yeah, they're sort of in the similar ballpark, but you can't tell much more beyond that. All right. So I'm going to jump back to PowerPoint here. There are some special things. Let's go ahead and load this. About area. So this is a map of Europe and the Middle East, and it is being colored by GDP spending. Position geography is actually a position. It's encoding context. And now we're applying color to our quantity. So it's an interesting visualization. What might you assume and take away based on this visualization? That the Middle East spends more money on their, or sorry, this is a share of military spending on GDP. Left that fact out, that's maybe helpful. What might you take away then, knowing that the color denotes, especially yellow denotes, share of GDP spending? Yeah, based on this map, it actually seems like the Middle East spends a lot, right, on military spending? But in fact, they spend far less than Europe does, right? So what I put on size here is the absolute amount that is spent. So when we look at these two visualizations side by side, they're actually telling someone a different message. And so when you use size, it's really important to understand that that the size of the country is actually lending more information into the story than maybe you intend. So this is something to be aware about, especially in Tableau. We use a type of map that maybe isn't the best in sharing area. And so this is Texas down here, and this is Texas and Greenland. And so when you are looking at geographic information, particularly within the world, you need to pay attention to make sure that the size of the country and the type of map being used isn't shifting the analysis and the story that you want to tell. So that is the one thing that you really need to pay attention to when using maps. I also want to talk about another special thing of position. So who was in devs on stage this morning? Some hands. Oh. And who watched it online? Were there more hands? And the rest of you just were out playing craps really late last night? Well, no, I'm sort of excited because I get to share something with you that a bunch of you maybe don't know. So this morning, Tableau released a new feature. It's a really awesome feature. It's mark animation. So in this viz, this is a viz of US music revenue by format. So 8-track tapes on the bottom, CDs. Over the last 40 years, CDs have far outsold cassettes, vinyl, digital, and streaming. But if I start removing the decades, we can watch as streaming moves from the bottom up to the top. So there's 80s gone. Now we're just looking at the 2000s, 2010 to present. So animations are a special type of position. They allow a relativeness between 2 points of time. I'm going to show you another one here, and this is maybe the best visualization that I think we made for devs on stage here. So this is a recreation of Hans Rosling's Gapminder. And pay attention to the red dot of Iran over time. Each of the different continents is denoted by a different color. And what's happening is the average family size is on the bottom, and the average life expectancy is on the y-axis. And what you can actually see is as the average family size decreases, life expectancy actually goes up. These are correlated measures. And you can actually watch what happens to Iran specifically. And so this visualization is great. I'm actually going to pause it here. Let's see if I can pause it. We'll just move here. Because we need to use animations sparingly. The one thing to remember about animations is we are very sensitive to movement. And so if I keep playing this animation, you will not listen to me. You can literally not hear what I'm saying. And so it's really good on animations to animate and then stop. Because it is so powerful, more powerful than position, size, color, shape. Well, I guess it's a type of position, but the in a moment position, that it will overpower every other message you are trying to say, because we are so fascinated. And that's because I think we're trying to understand if there is a threat happening to us. Movement used to mean a threat to us. So when you're in a restaurant and someone like walks in, you're like, oh, what's going on? What's going on? What's over there? It really annoys my husband. He's in the room somewhere. It's all my brain. It's not me, I promise. Hans Rosling is probably the person who made data visualization famous. If you haven't read this book, Factfulness, I would highly, highly recommend it. So we just have a couple minutes left. I know we went over, so do you guys mind staying just a couple minutes? What I want to tell you is there is a difference between function and form. Function is about speed and accuracy. Form is about aesthetics. Sometimes in visualization, we confuse these two things. In the effort of trying to have form, we lose what message we're trying to say. I think that we have come really far. I think maybe Apple is the best example of someone who's taken function and form and brought them together. So we've talked about color, we've talked about position, we've talked about size, we've talked about shape. I'm going to go ahead and look at the iron vises and then give you an opportunity to vote on who you think is the best practice, and we'll talk about them together. So this is Joshua's example here. He looked at the taste of America, and it did not update, did it? There we go. So this was Joshua's example of the taste of America. And Joshua's premise was he used color really well. He actually got asked about this, about why he used blue and defaults on the left. Who remembers his answer? Yeah, because Tableau's done the science for him about what's best. But he also used blue on the right-hand side, and I think that was confusing to a lot of people, because we have to be careful not to use the same color to denote different things, because our brain is applying categorical information to it and saying, blue and blue, those must be the same things, even though in this visualization, the blue on the left and the blue on the right are different things. Same thing on the top, he has orange and red, but he's using it in a different way on that bottom map. What is cool, what I think he did really well in this visualization, is that map in the bottom right-hand corner. He's getting around the whole states have a different geographic sizes by geographically showing where they're at, but representing them by the same size box. Okay? And so I think he did a really, really great job at that. I think this visualization in the bottom is probably the best part of his viz. Okay? And in fact, there's something that maybe you didn't see before was this line here, where he's actually taking each state and showing the position of it, its relativeness. And I thought that was really cool. And then he went and he switched over his map. And he said, what's missing? There is data that is not here. There are countries that are just not represented at all. He said something like, of all of the African cuisine out there in the United States, something like 85% of it is just categorized by Africa, even though there are some 70, 80 countries in Africa. And so he was making this case and using color really effectively to show what is missing. Lindsay took Kelly Martin's approach to data and data visualization. She used color to denote the same categorical information across all of her vises, right? So Subway is represented in pink, and so it's really clear on this line graph here that this line is Subway. And I can tell that 7-Eleven is represented in orange down here. One of the things that I think Kelly could have done better is she could have better leveraged position. It's really hard on these upper visualizations to tell the relativeness of how Subway compares over zip codes, locations, and population represented. And so if maybe she had stacked these on top of each other, we could have gotten more insights from the data. Finally, Hisham made this visualization. Hisham chose to use two colors, a red and a yellow, to denote diverse cuisine versus traditional cuisine. Traditional cuisine was when over 50% of a country's cuisine was represented by their own cuisine. Somewhere like Greece, most of their food is Greek. Where in the United States, most of our food is from another country. Actually, over 50% of our restaurants in the United States are Mexican restaurants. That was really, really interesting. And he's using that red and yellow across the visualization. And even though he has red and yellow on the map on the left, the position of his bars down here make it very clear to a user not to be confused about the size representation here. And then he has gone ahead and combined a bar graph showing position with another level of data. Here is each of the cuisines. And I'm actually going to switch over to the viz itself so you can see how it works. So if I select a country like the United States, here, the map will update. I can see just the United States here, and I can see, in fact, Mexican has the most cuisine. Okay. So I'm going to go ahead and I'm going to put a URL up. I want you to go ahead and vote, and we will actually crown, and they will get an additional small trophy as the best practice viz from this group. So let me go ahead and put that up for you guys here. So go ahead and if you text TC19 to 22333, you can go ahead and vote on who you think had the best practices. And as it comes in here, you should be able to vote A for the black and white viz, B for Lindsay's viz, and C for Hisham's viz. And then if you didn't know, our Iron Viz Championship yesterday resulted in a tie. And some of you might have some questions about that. It actually turned out that they were within 5 decimal places of the same answer. It was a dead heat between the two. So one scored a little higher with judges, the other scored higher with the Twitter vote, and it came out to a dead tie. So we can maybe break the tie a little. And so the votes are still coming in, but it's starting to look pretty apparent that we do have a best practices winner. And I would agree with you all that C was the one that used best practices to the best. Thank you for joining us today. I hope you have a great rest of the conference.